welcome you all on this new lesson. Every student of aviation is bound to start with this particular lesson called the aerofoil. Today in this lesson I am going to explain to you the shape of the aerofoil. This is a very shape that it gives the ability to provide the upward lifting force to sustain the flight. The shape is peculiar, and the characteristics have been studied over several experiments in wind tunnels and everything, and the theory has been derived thereafterwards using experimental and a part of the theory. So let's learn some definitions and characteristics to get a better understanding of the aerofoil. The first definition of an aerofoil which we shall learn is of course the most important one, is the chord line and the chord. Chord line is a line which connects the leading edge to the trailing edge of an aerofoil. Chord is the distance between the leading edge and the trailing edge of an aerofoil measured along the chord. Line is the chord. It is actual length. This is a very important parameter, as you will learn and understand all through. Different shapes and different types of aerofoils are defined based on this length, fundamentally on this length. And of course, there could be other parameters which also can be affecting, which is what we are going to learn. But the length by itself remains the most important and the most differentiating in characteristic of each aerofoil. The next definition which I would like to explain to you may not be exactly of the aerofoil but of the wing. In any case, the wing shape and the aerofoil is sometimes used synonymously, so they both mean the same things, since aerofoil on standalone doesn't have any characteristics. Anyway, the definition which I am trying to talk about is the span, wing span. Wing span is the wingtip to wingtip distance of any wing which is as shown. I have shown a frontal view and a wing standalone view just to give you a good idea as to what is the wing span. The next important characteristic which I will talk about is the aspect ratio. The area of the wing is an important parameter on which several characteristics of the wing and its behavior is determined, especially the lifting capability, etc. Now we learnt about span. So this aspect ratio is the ratio to the square of the span divided by the area of the wing. Most of the wings are not rectangular in nature, but just to make our understanding very clear, if we were to work on a rectangular wing, span squared by area will be the aspect ratio, whereas the area will be the span into chord. Therefore, it works out for a rectangular wing. The aspect ratio is the span by chord. Sometimes it is used as span to chord ratio also. Next important definition which I would like to explain to you is the mean aerodynamic chord. The chord line that passes through the geometric center of the plan area or the centroid of an aerofoil is the mean aerodynamic chord, and for any platform is equal to the chord of the rectangular wing having the same wingspan and the same pitching moment and the lift. Anyway, let's not ponder too much on this definition, but suffice to tell you that it is the geometric center of the plane, which means that the center of gravity is assumed to be passing through that point or line. It is usually located approximately 1/3 of the semi-span from the wing root. The mean aerodynamic chord is often used, as I told you, to locate the center of gravity and carry out studies with respect to stability issues. The next definition is the quarter chord line, a line joining the quarter chord points along the length of the wing is the quarter chord line. A line joining all the points of 25% of the chord measured from the leading edge from the aerofoil. I am going to go through two basic definitions. The mean geometric chord. This is the average chord length of an aerofoil all along the wing span length. It is an average. There are special ways to calculate. So it is just called the mean geometric chord. And of course, there is something called the root chord, the line joining the leading edge and the trailing edge of the wing at the center line of the wing, at the root of the wing. At the root of the wing is called the root. Okay, we are going to define some more important parameters or definitions. The mean camber line. The mean camber line is the curved line joining the upper and lower surface of the aerofoil all along the aerofoil. The shape of the mean camber line is very important in determining the aerodynamic characteristics of an aerofoil section. The max camber, that is the displacement of the mean line from the chord line. Chord line, as you will recall, is a straight line. Wherever this mean camber line is displaced maximum is an important parameter, and the location of the max camber help to define the shape of the mean camber line. These quantities are expressed as fractions or percent of the base chord dimensions. That means the max camber will be the distance of the maximum displacement of the mean camber line from the chord line to the chord line into 100. So a typical low speed aerofoil may have a maximum camber of 4% located 40% at the aft of the leading edge. Next is a very simple one, nevertheless important one. The point of maximum thickness. The point at which the aerofoil has its maximum thickness. The thickness is the distance between the upper and the lower surface of the aerofoil. This, wherever it is maximum along the chord line, expressed as the distance of the maximum thickness expressed as the chord, a percentage of chord is called the point of maximum thickness. A typical low speed aerofoil may have a point of maximum thickness at 12% located 30% aft of the leading edge. Next parameter is another equally important parameter which I am going to define, the leading edge radius. The leading edge radius of an aerofoil is the radius of curvature at the given leading edge shape. The leading edge normally is well rounded, and for a high speed aerofoil may not be that well rounded. So this is one of the important characteristics of an aerofoil. It is the radius of the circle centered on a line tangent to the leading edge camber and connecting tangency points of upper and lower surfaces with the leading edge. It's also referred to as nose radius. Let's not ponder too much over the exact definition. It's just sufficient to understand for us that the leading edge shape, the curvature, if you were to draw a circle which will touch the tangent points of the upper and the lower surface, and the radius of that particular circle is called the leading edge radius. The next definition which I would like to explain is the axis of the aircraft. There are three axes of aircraft which are defined to define the movements of the aircraft in its three-dimensional plane. First is the normal axis, is the line joining from top to bottom. Then is the longitudinal axis, is the line joining the leading edge, that is the nose of the aircraft, to the tail of the aircraft. And of course the lateral axis, which is a line all along the maneuvers of the aircraft. So it is as shown in the picture. The next one which I want to explain is the wing plan. It is the tilt of the wing with respect to the lateral axis. If the wing were to be tilted upwards with respect to the lateral axis, it is called the wing dihedral. And if the wing were to be tilted at an angle lower than the lateral axis, then it is called the anhedral. Here in this picture, I have shown two examples, one of an Airbus 320 which has got a wing dihedral and an IL-76 which has got an anhedral. What are the advantages of such wing planforms is a subject for future discussions in future lessons.